And that's, tangent and cotangent, these two numbers add up to 90. They're all the cofunctions. Um, so again, tangent of 24 goes with cotangent 66. But when it's a 1 over, that means it's 1 over whatever the reciprocal is, which happens to be tangent.
Okay. And then how would like 31 and 32 work?
So they're the same. It's just that if you're not comfortable with radian, you might not recognize it right away. And what you don't want to do is convert to degrees, but it is clearer if you do it in degrees. Pi over 3 is 60 degrees. This is 30 degrees. You just might not recognize right off the bat that pi over 3 plus pi over 6 is pi over 2.
Okay, yeah.
But it is. So the same thing for the sine. These 2 pi over 3 and minus pi over 6, um, that also adds up to pi over 2.
Could you explain that again?
So you just make it a common denominator for that. So it's 4 pi over 6 plus minus pi over 6 is 3 pi over 6, which reduces to pi over 2.
Oh,
And so
okay.
so if they add up to 90, which is okay, you're it's the one that pairs with it.
Okay.
So the cofunctions, um, sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. And I mean, you could have positives or negatives. You could say like the sine of 120 degrees equals the cosine of minus 30 degrees. Like that's okay.
Yeah.
And then, as you saw, it could also be like the reciprocals. Uh, this is secant of minus 30 degrees. That would also be possible.
Okay. So no matter what the function is, you just focus on the numbers and make sure they equal 90.
Yes.
Okay.
Right. Okay, so that's kind of the first grouping of questions. The next grouping um, uh, is kind of the same, but I guess a little bit more involved. Um, I remember us doing some of these at some point a while back. So the idea is that in any one of these are all still cofunctions. So we'll just pick a couple here. Maybe I'll pick the evens. 38 38 here. So the idea is that you just pick one and you pick the more complicated one, 2 theta plus 30. This has to equal 90 minus the other. Or if you don't like that, you could say theta equals 90 minus 2 theta plus 30. You'll get the same answer. That's the whole idea of the cofunction.
Okay.
So, I mean, I'll solve the one. You can solve either of these. It ends up being 60 equals 3 theta. Theta equals 20. On the right, same thing. You get 90 minus 2 theta minus 30 theta. So you end up getting 3 theta equals 60. Theta equals 20. And be careful that it's not just about finding theta. Sometimes they want both angles. It might be 20 comma 70 as an example. So where it gets a little more difficult is with radian. Most students are just not that comfortable with radian. But you just pick one side. You say, okay, I'm going to start with x. So x equals, instead of 90, it's pi over 2. 90 degrees is pi over 2 minus pi over 12.
And then just solve for x.
Yeah. In this case,
Oh,
it's just making a common denominator. It's a 6 pi over 12 minus pi over 12. 5 pi over 12 is x.
okay.
I know the last one's most difficult, but why don't you try it? Um, see if you have any questions. It is in degrees.
So theta minus 10 degrees equals 90 and 2 theta minus 20 degrees equals 90.
All right, so we never did that in any of the previous problems. So we only had a 90 on one side or a pi over 2 on one side. I was just in this first one, I was showing you that you could do it either way.
Yeah.
So you pick one to stay the same. Which one do you want to stay the same? The first one or the second one?
First one.
Okay. And then the second one is 90 minus whatever it is that's given.
Okay. So it'd be negative 2 theta plus 70. I mean, plus
Yeah, go ahead and solve it
10.
all the way through. Get a value for theta, please.
Would it just be 90 minus 2 theta plus 20 equals theta minus 10?
You have to solve the equation for theta. Theta is just a variable, just like x.
Would we distribute the negative, I mean the minus in front of 2 theta?
Yeah, they both. I think you said it right. I mean, it's just a linear equation, variables on both sides. Move the variables around to get one on one side and then hit the
Is
numbers
it
on the other.
40 degrees?
Yeah, so theta equals 40. And then your check is if you put it back in, 40 minus 10, 2 times 40 minus 20. So that becomes cotangent of 30 equals tangent of 60. Is that true? Yeah, it is. Cotangent, sorry, not cosine. These add up to 90. Good. Okay. Any questions on that, thoughts on that before we move on to the next grouping? Or do you want to try
Okay.
41? I think you should try 41 actually on your own here. It'll probably go a lot faster. Why don't you do that? Then we'll move on to the next.
Is it 20?
All right, so theta equals 20. And yeah, you end up getting a 45 here and 45 here. So it does in fact work. All right, very good. The next grouping of questions are kind of your starter sum and difference formula questions. So we'll pick a couple of these. You do have to know the sum and difference formulas. There are 3 of them. I can send you that reference sheet again if you need. I'm just going to grab the snip from it. The most students complain that they have to remember these. It's not great, but there is some kind of there's some things you can do to remember this. Um, the way these read is you see this plus on top of the minus. If yours is a plus, use the top one here. The top goes with top and bottom goes with bottom. So the plus goes with the plus, the minus goes with minus. For cosine, the plus goes with a minus in between there. Sometimes there's some confusion
Oh.
about how to use these formulas. Same with the tangent. The plus goes with the plus, but then it goes with the minus on the bottom.
Hmm.
So we'll do a sine and a cosine, except these are all cosine. I don't know why these are all cosines, but they are very odd. So let's do 44. 44 is cosine 90 minus theta. So for the first few, I will put the formula right underneath. It's really important to have the formula. Like if you got to memorize it somehow. And then what you have to do is you have to be able to know, well, which is alpha, which is beta. Your book might use X and Y. So in your problem here, alpha is 90 and your beta is theta. Okay, which I was a little confusing with two letters, but it's never this operator. That's the whole point of me why I chose this problem. It's never, this is never negative. The first one's never negative. It's always, well, there are some exceptions, but usually the first one's alpha, the second one's beta. So this becomes cosine 90, cosine theta. Because it's a minus in here, the minus goes with the plus on the bottom. Sine 90, sine theta, like that. And if you haven't done this, it'd be good for you to really make sure you work this out and see. And then you have to know what cosine of 90 is and sine of 90 is. That's on your unit circle. You're up here. It's 0, comma 1. The x value is cosine. So cosine of 90 is 0. Sine of 90 is 1. So this becomes cosine theta times 0. 0 times cosine theta plus 1 times sine theta. And you can see that it just becomes sine theta.
Okay.
All right.
Yeah.
So let's try let's do a sine now. I'll just make one up for sine because there's no signs in there. And we'll use some radian here. So we'll go sine of theta minus pi over 2. So this is a question to you. What is alpha and what is beta in this one?
Alpha's theta and then beta is pi over 2.
Good. Okay, so try writing this out.
So 90 plus cosine theta sine. Sine's 90 degrees, right?
Uh, I'm sorry, I didn't quite understand your question.
I mean,
So,
sorry, pi over 2 is 90 degrees, right?
yes, exactly. You don't want to evaluate it as you go. You want to kind of write it out. Is it a plus or a minus in the middle?
Okay.
It's a minus.
Wouldn't it be? Oh, wait, no, because it's facing the same way. So would we simplify pi over 2 to 90, or would we leave it as?
No, I mean you just got to figure out the number. You got to again, you're up here on the unit circle. So 0, comma 1, cosine is the x, sine is the y.
So we would, oh, okay. Should be sine theta minus, um, oh, wait, no, it would be negative cosine theta.
Yeah. So it ends up being negative cosine theta. Exactly.
Okay.
Okay. So I'm not trying to avoid 51 through 56. They're kind of more complicated. What I was hoping for, I was trying to look for it. I don't see um let's do um let's do so so what I'm not seeing are the problems that I kind of, to me, I associate with these sum and difference formulas, which is, maybe you got this in classes. They'll ask you to find like the cosine of 75 degrees, which is not
Mhm.
on the unit circle. Like it's absolutely not in the unit circle. Um, but there is an alpha and and a beta that add up to 45 degrees. And your most common numbers on the unit circle is 0, 30, 45, 60, and 90. So how can you get 75 from two of these numbers?
30
Either
and
added or,
45.
yeah, so cosine of 30 plus 45. Okay, so this becomes cosine 30, cosine 45. Now, is it plus or minus in the middle here based on,
Minus.
it's a minus, sine 30, sine 45, right? So now we have to find these values. And that's kind of where I thought you were going with this. It doesn't quite look like it to me, but we're going to do 51. We'll do one other example and then do 51 through 56. But did you see anything like this in class?
Yeah.
Okay. And that was kind of where I thought you'd be going. So this is square root 3 over 2, square root 2 over 2, sine 30 is 1/2, square root of 2 over 2. And then you have to simplify this. So this is, square root of 6 over
Minus root 2.
2. And then,
So then it'd
and then,
be root 6 minus root 2 over 2.
right. So sometimes you get kind of a funky ones, like it might ask you for the sine of minus 15 degrees. And so you have to come up with the subtraction of two numbers that that gets you to minus 15.
Uh,
And you typically want to use some combination of
7.
these.
Oh,
You got to use something that's on the unit circle.
minus 60 and 45.
So you would go this way: 45 minus 60.
Oh, yeah.
Could you also do 30 minus 45?
Yeah.
Yeah, there's plenty of possibilities. So let me grab the formula for sine, and why don't you work this out here for me, please, and then we'll move on to those other grouping of questions.
Sine 45, cosine negative 60, minus cosine 45, sine negative 60.
And keep working that out. Go as far as you can on that.
Sine 45. Could you pull up the circle?
So why don't I send you the reference sheet? That way you've got it again. Um, it's always better if you are looking at, then you're used to where you define stuff as well. I remember I said you kind of only need to know the first quadrant. That's big here where you can sort of save some time if you are pretty quick at this.
Root 2 over 2 times root 3 over 2 minus,
Cosine 60 is the X value there.
oh, sorry, 1/2
And the answer doesn't
minus
the answer
root,
doesn't mean much. So just, you if you put the wrong number down, you won't have any way to know. That's why I corrected you there.
yeah, root 2 over 2 times root 3 over 2.
Okay.
Um,
How do you reduce that?
root 2 over 4 times, I mean, minus root 6 over 4.
Those Does that kind of resemble what you were doing in class?
Yeah.
All right. There's other ones that they can get to. It's not just these numbers. I mean, you can do 120. I mean, it's yeah, there's no limit to what the instructor could do there, but there is a limit to what we can do to prepare you. So,
Yeah.
all right. The next grouping of questions, the thing I want to focus on is the triangle stuff. And we'll do like 52 here to start out. But you can see you're just doing sum and difference formulas for it. So let's look at 52. You have to draw the correct triangle. And I made this comment once before. It looks like a bow tie. These are the reference triangles in each quadrant.
Mm-hmm.
So you're in quadrant 3. So in quadrant 3, this is what the triangle looks like. There's S. Where do well, we've already done it. So it's 8 and 17. That's negative. Do you remember how to quickly find the other side, or do you remember the Pythagorean triple?
Um,
If
Pythagorean
not,
theorem.
you do have to use Pythagorean, but like some of them are well known, like 3, 4, 5s are well known, 5, 12, 13s. This one is one of them.
8, 17.
The 17 is the biggest number, so it's between 8 and 17. It ends up being 15. Is it positive or negative?
Negative.
Negative, yeah. All right. And the reason you do this is that that gives you sine of S. Sine of S is negative 15 over 17. And we haven't done one yet, but then you would get tangent of S if you needed it. We similarly have to do one for T. So this is minus 3 over 5. What is the other side here?
Negative 4.
Negative 4. So what is sine T?
Sine t is
Opposite over hypotenuse.
oh, negative
So
4 over 5.
yeah. All right. Now the question asks you to find cosine S plus T. And that's the sum and difference formula. That's what we've been doing over and over and over again, right? Um,
Mhm.
so you go grab the formula and if you write it down every time, I know I'm copying and pasting. I don't need to remember these. I can always look them up. But you have to remember them. You'll start to notice the pattern. You'll be like, oh yeah, I see the pattern. It's cosine, cosine, sine, sine. And then this time it's subtraction in between.
So would it be 8 over negative
So you
8
got
over
you got now you go back and grab. So the cosine of s is minus 8 over 17. The
cosine of
cosine of,
t is minus 3 over 5.
yeah. And then
And
sine
then
of s,
negative 15 over 17 and negative 4 over 5.
you got it. Perfect. Then you have to simplify. Well,
Um,
you're just putting those numbers into the formula. And then
24 over 85.
yeah,
And then minus 60 over 85.
yeah, no, they should always have the same denominator. So that's a check
Yeah.
if you're not doing it right. So it ends up being minus
It's
36.
36 over 85.
Got it. And so what else could they ask? Well, they could ask you for the cosine of s minus t. They could ask you for the sine of s plus t, the sine of s minus t. They could flip the order. They could ask you anything, but it all comes down to drawing the triangles. Okay, so let's do 54. So the quadrant 2 looks like this, and it's always the angle made with the x-axis. And then t is in 4, that looks like this. Again, it comes from knowing the references. That's t. So that's 2 and 3, and then t is -1 there. So could you find the missing sides of the triangles, please, with the correct sign as well? Make sure you count for sign.
Cosine would be,
No, no, no. You gotta find the missing side. Pythagorean theorem.
oh,
Pythagorean theorem. And then you give me cosine s.
is it 1, 2, 3?
Pythagorean theorem. It's I mean, if you're going to call it a, it's a squared plus b squared equals c squared. A squared plus 2 squared equals 3 squared.
6 minus 4 equals 2.
It's 3
So
squared
root,
is not is 9.
oh, 9, sorry. 9 minus 4 equals 5. Then 1 plus something equals 9.
Yeah, so the you want to do the same thing on this one?
2 root 2.
Yes, 2 root 2. Now you're missing your signs. You got an issue with signs. The one on the left here, and it's easy to do because you're so focused on getting it. It ends up being negative. And if you're wondering why is it negative, it's because you're going left from the origin. All right. So now give me cosine of S now.
Uh, -√5/3.
Good. And cosine of T.
2 √2 over negative. Oh, wait, no. Over 3.
This time, let's have you do sine of S minus T. And I'm going to go grab the formula because I don't remember, but just get some practice. And we should, if we have time here, we should do a tangent one, although, well, maybe you may not have been doing tangents in class.
Sine 2/3 times -1/3
Okay,
minus -√5/3 times 2 √2/3.
good. And you see how they have the same denominators? It's to be expected. Like they don't have to match like number for number, but when you multiply them, they end up being the same.
Mm-hmm.
So it's -2 plus 2 square root 10. What does that mean? A great question. No idea. Okay. Um, did you do any tangent sum and difference in class?
Yeah.
So they don't often work out like all that great. So, we just, it's the same idea as this. So let's make up a problem here. Let's say, and I'll keep it in the first prod quadrant. So let's go. Um, let's say this is 3, 4, 5, and we want the tangent of x minus y, and y is, we'll go fourth quadrant here, and we'll just do the same thing. We'll do 4, -3, 5. Okay. So let me grab the formula for that. So you can see it's a bit more involved. It's got a fraction. It's going to be tangent of x plus tangent of y, 1 minus tangent x times the tangent of y. These signs, these operators plus and minus, they always flip. So if it's plus on the top, it's minus on the bottom. It's minus on the top, it's plus on the bottom. That's another thing to help you remember.
Mm-hmm.
this is about the nicest one I can give you that otherwise they just get, they're very, very awful. But you want to try simplifying this one for us, please?
3/4 plus, I mean, 3/4 minus 3/5,
Remember, tangent is oh, oh,
opposite over
yeah.
adjacent.
So 3 over
Oh, wait, no,
4.
-3/4.
Yeah. Now this one, it doesn't end up mattering what the bottom is because the top is 0.
0. So be
That is the
undefined.
nope, no 0 on top's okay. That just means 0. So it ends up being 0 over whatever, but it just ends up being 0. So one you might get, so we'll just keep it kind of simple. Let's say it was tangent of 45 plus 45. You want to try this one for us, please?
45 would be
1 minus tangent
Oh, you just
45.
automatically sub it in?
Yeah,
I thought you had
yeah.
to
I
do
mean,
like the 45, 45, 90 triangle.
no, I mean, if they give you alpha and beta or the X and the Y, you can just put them in here.
Okay.
So could you try simplifying this for us, please? Let me know if you need me to go grab that unit circle piece again.
I can pull it up.
Okay.
Uh, 1 plus 1 over 1 minus 1 times 1. So 2 over
And when
0.
you,
So 0.
this is undefined.
Oh, this one.
0 over a number is 0. 2, 2 over 0, any number over 0 is undefined.
Okay.
All right. All right, we're going to stop there for today.